Welcome to the Polaris Project. My name is Asher Verlee. I'm the captain of the NASA HUNCH Team Polaris. This is the first of our weekly update and documentation videos, where I'll be walking through our process step by step over the course of the season. The goal here is to show how we go from a blank page to a working robot, sharing the systems, research, tools, and ideas that shape the process. We started the season by setting up our ClickUp workspace using an agile system. Every task, from mechanical prototypes and coding experiments, now lives in one space. This helps us break the season into manageable sprints, track dependencies, and make sure we're documenting as we go. A lot of robotics projects fall apart because notes get scattered or progress isn't tracked. We want to avoid that by treating organization as seriously as design. We also launched our season GitHub. This is where all of our code, research, and experiments will be stored. Using GitHub makes it possible to collaborate across different machines, roll back mistakes, and keep a clear timeline of how our software evolves. It also forces us to write meaningful documentation, which, if you've ever looked at a half-finished robot codebase with no comments, you know why that's important. Our technical research for week 1 focused on 3 main areas: monopedal jumpers, 4-bar linkages, and reaction wheels. Jumpers and linkages help us understand different locomotion styles, while reaction wheels open up ways to stabilize and control robots without relying on external support. Reaction wheels in particular are something we will be implementing this season. They're mathematically complex, but also elegant. They let you generate torque inside the robot itself, balancing or even flipping it without it ever touching the ground. Our Bambu Lab printers have already played a big role this week. Rapid prototyping means we can validate designs quickly instead of waiting days or weeks for outsourced parts. It's been 2 years since we purchased the P1S, and at some point I'll be doing a full review, but for now what matters is that they've enabled us to go from CAD to physical parts to physical parts in a matter of hours. Since this is our first update, I also want to highlight the team. Polaris isn't just me, it's a group effort with people contributing in design, coding, research, and documentation. My face will be the one you see most often in these updates, but behind the scenes, everyone is moving us forwards.
Hello, my name is Austin Ladine, and I am the research lead at Team Polaris. I'm also a software student and CAD student with the team.
Yo, what's poppin'? I'm Jack LaFender and I'm the Polaris software lead.
Hi, I'm Lyle Scanlon. I'm a software student, but I do a little bit of everything for the team.
Hello, I'm Hunter Carlson and I am a software student and the lead fabricator for Team Polaris.
So overall, week 1 was about laying a foundation. We now have a system to manage tasks, a GitHub to handle research, a first round of mathematical exploration into how we'll approach mobility and stability, and the start of a simulating environment for machine learning. The printers are running, the team is organized, and the season is officially in motion. If you've enjoyed this behind-the-scenes look at the Polaris project and want to see where it goes from here, consider subscribing. Each week, we'll share progress, insights, and challenges as we work to push this project forwards. That's it for now. Thank you all for watching, and I'll see you in week 2.